All right, welcome to page 3 of the review. These are going to be mostly word problems. So to start us off, whoops, I can't. We're going to read through this. So I am bright gets into her car and travels east 5 miles per hour for 1 hour. So she's going to go straight this way. We're just going to make a note that it's 65 miles per hour and for 1 hour. Then she turns north and goes straight up. And I'm going to make a note that she travels 50 miles per hour, but for 2 hours. They want to know how far away she is from her starting point. Okay, so if she traveled 65 miles per hour for 1 hour, that means she traveled 65 miles. If she traveled 50 miles per hour for 2 hours, that means she traveled a total of 100 miles, and we'll call this our C, because here's where our right angle is, and remember, across from our right angle is always our C. So this is a basic a squared plus b squared equals c squared problem. So a squared is 65 squared. She traveled north 50 miles per hour for 2 hours for a total of 100 miles squared equals c squared. So 65 squared plus 100 squared gives me 14,225, and then I square root. So the distance she is away is approximately 119.27 miles. So that means from her starting point, she is 119.27. Right, now we're going to move on to some more word problems. Okay, so this is a pretty standard problem that's going to show up on maybe even ACT types questions or a final or something, because it really tests you on properties of a square and right triangle. So I have a square here, and the perimeter is 24 centimeters. And the length, they want us to find the length of the diagonal. So I'm just going to draw one diagonal in, because if I draw one diagonal in, I've just created a 45, 45, 90 because the angles are 90, and then if I draw a diagonal, I've cut that 90 degree in half. So I know the perimeter is 24. I know that each side is 24 divided 4, which gives me 6. So each one of these sides has a length of 6 centimeters. Again, in a 45, 45, 90, it's x, x, x square root of 2. So to get the hypotenuse here, all I'm going to do is times by the square root of 2. And I've now found the diagonal to be 6 square root of 2 centimeters. Now, if you didn't remember that, you could also do a squared plus b squared equals c squared, and get 36 plus 36 equals c squared, and get 72. And then just at the end, you'd have to simplify that. So 72 is the square root of 36 times the square root of 2, which would leave me with 6 square root of 2. So I would hope that you would recognize the 45, 45, 90 in a square, but if you didn't, you still can use a squared plus b squared equals c squared. All right, now this one's a little bit trickier. It says the diagonal is 24. So just remember, in a 45, 45, 90, the sides are x and x, and to get the hypotenuse, you times by the square root of 2. So the opposite is to go backwards and divide. So to get this side right here, or any of the sides really, I'm going to take 24 and divide it by the square root of 2. Can't leave my answer like that, so I'm going to times by square root of 2 on top and bottom. So I get 24 square root of 2 divide 2. Again, 24 divided 2 is 12, so I'm left with 12 square root of 2. So each one of these sides is 12 square root of 2. So the question asked me, find the perimeter. So I'm going to take 12 square root of 2 plus 12 square root of 2 plus 12 square root of 2 plus 12 square root of 2 for a total of 48 square root of 2. Remember, when I'm adding, I just look to see if they're all the same on the inside of the radical, which they are. So I just add the numbers out front. So I just add 4 12s together, which gives me 48 square root of 2. Right, and now we get to the infamous problem that involves algebra. So a telephone pole has a height of 40 meters. In a giant storm, the telephone pole is struck by lightning and snaps. The pole fell in a way so it is still hinged as pictured below, and the tip of the telephone lands 20 meters away from the base. So I want to find out how high up did it break. I know that this is 20 meters down here, but I don't know what the hypotenuse is. So think about the telephone pole. It was originally 40 meters tall. I am trying to figure out how high up it broke, so that's x. So what's left is going to be 40 minus x. So the hypotenuse here is 40 minus x. Now I'm just going to set up a squared plus b squared equals c squared. So it's x squared plus 20 squared equals 40 minus x squared. And this is where algebra comes into play. So I have x squared plus 400. And remember, I need to FOIL this out. So if I see a squared, I'm just going to write it twice. And then I'm going to say to myself, all right, to FOIL, I'm going to distribute. So 40 times 40 is 1600. 40 times a negative x is negative 40x. Then I'm going to distribute the next set. So negative x times 40 is negative 40x, and negative x times negative x, negative times negative turns into a positive, and x times x is x squared. Okay? All right, so now we need to solve. The x squareds on both sides are going to cancel each other out, so I'm down to that. I'm going to minus the 1600 from both sides, so I'm left with negative 1200 equals negative 40x, and negative 40x equals negative 80x. So last step, divide by negative 80. X equals then 15 meters, which means that it broke 15 meters up, and 40 minus 15 leaves me with 25 meters for the other end. Okay? All right, we're on to the last one for this page. This one's a little bit longer. So we have a carnival tent for animals. So remember when you set up a tent, if this is like the pole, you always got to stake a tarp to the top. So you put a little stake right here into the ground to make sure that the tent stays up. So they originally want to set the tent to 10 feet high. And they have a string that's 15 meters long to stake it down. So this is 15 feet. Okay? So they're asking us first to find out how far away that stake is, because we don't want it to be too far for people to trip on. So we're going to write 10 squared plus 15 squared. Oops, not plus 15 squared. Excuse me. Don't listen to me. We're going to write 10. Oh, gosh. We're going to write x squared plus 10 squared equals 15 squared, because 15 is our c, which is our hypotenuse. So I get x squared plus 100 equals 225. X squared then equals 125 when I subtract the over. And this one it's okay to get a decimal, so I'm going to take the square root of 125, which is 11.1. So the original distance is 11.18 feet. Now what happened is they noticed that they had to raise the feet by 2 feet to ensure the elephant could fit. So instead of being 10 feet, it's now going to be 12 feet. Which means they still have to use that 15 feet string, which means that it's, oops, that's not a very straight line, but it's my hypotenuse, just ignore that fact. So it's going to be a little bit closer to the tent now because it can't reach as far out. So they want to know what's this new distance here. So we're going to call that x. So now we're going to do x squared plus 12 squared equals 15 squared. So I get x squared equal, or plus, oops, my computer is being really slow right now. 144 equals 225. So I get x squared equals 225 minus 144 gives me 81 square root. And this one's nice. Square root of 81 is 9 feet. So I started at 11.18 away, and now I'm at 9 feet. So it says how much closer to the tent will it be? I'm going to take 11.18 minus 9 feet, and I will get 2.18 feet closer. Which means less people are going to trip over it, hopefully, since it's not sticking out quite as much. Okay? All right, there's about 4 questions left on the back. Please watch the last video if